Ladies and gentlemen, welcome back to our YouTube channel. Today we will continue to learn Plaxis 2D version 2020. Today I will introduce you how to simulate point static load test in Plaxis 2D. And now I will show you the case study. You can see here in the left side, this is our model. The width of the model is 5 meters and the height of the model is 15 meters. This is the soil layer with a 6 meters and this rock layer with a 9 meters. And you can see here, this is our point and the length of the point is 11 meters at the elevation is 4 meters here. Is the positive elevation. So this is the interface. We extend the interface 500 mm from the positive below. So in this is the table 1. This is soil. This soil parameter. You see this is for the point, the concrete point, and for the soil in the top layer, and for the soft weather rock in the bottom layer. And this is some information of the loading state and the unloading state. For static load test, we will do the loading state, and after the loading reach the maximum value of the load, we will unload it. And this is unloading state. And you see here for the loading state, we have the step load at 0, 200, 400, 600. 800, 10,000 and 10,200. So this is the point. This is the not the point. This is the load, static load in the point head. And to model, we will use this is the line load with the you see the unit of this line load is kilonewton per meter, and per meter is mean per meter square. So we will calculate the uniform load by divide the P. P is mean the load to the area. The area is calculated from the diameter of the point. So we have the value here. So I think it's easy to calculate. You can do it by yourself. And now we will go to the Plaxis program. And first we have to open the program and start new project. Now we put the title Point Static Load Test. This is GASC is mean geotechnical and structural engineering. And the model we use this model asymmetry, and the element we use 15 node element. For the x mean 0, x mass is 5 meter, y mean 0, y mass is 15 meter, and click OK. Now we will create borehole by click on this, and at 0, 0 we click on this and we click add. At the first layer we will assign this is the soil layer. We will use small clump and trend condition, and for the gamma here it is 18 and 20. For the parameter, we use the elastic modulus. It is 3E3. And for the portion ratio, you see 0.3. Okay, for the cohesive, this is 21, and this is the friction angle. This is 30. So in this case, the interface we will use the rigid is the R interface 1 and click OK. Now we will define to the rock layer. We also use the more column model and train condition. Now we will input this 24 and 26 in the parameter E5 E4 and the portion ratio 0.3, and for the cohesive it is 42 and the friction angle is 40. In this case, we also use the R interface 1 and click OK. Now we will define the pie material. For pie material, we use the linear elastic, and this we use non-porous. For this we will input is 25, and in the parameter for the elastic modulus we will input 5 E4, and for the portion ratio we use it's not 5.4, sorry, it's E30 E6, and now it is 0.2, and all the value we just give it before, and click OK. So click OK. Now we will define the geometry for the soil. The top layer at 15, the bottom elevation of the soil is 9, and the raw water we keep it at the bottom. Okay, and click OK. Now we have our soil model here, and we move to structure tab to create the pie. Before create the pie, we will click on this to change the snap interval to 20. Click OK. We zoom in and we click on this create soil polygon. Click on 0.15. Also click on 0.4, and you click on 0.254, and also here we will click on this 0.25 and 15. Click and right click, press ESC, click on this. Now we have pie here, and we have to create the load. You click on this and click on this, right click and press ESC to access. Now we finish the creating of structure. Now we move to generate the mesh. Click OK. Oh, we forgot one thing, that we have to create the interface. Click on this, and for the interface between the pie and the soil, I want to extend it a little bit. Let's say it is about 500 at 0.25 and 3.5. I click, you can see, and at the second point I click on this point, right click and finish. Okay, so now we finish this structure tab and move to generate the mesh. Click OK. Now we will view the mesh. you open it. Okay, finish. It looks perfect. Imagine creating with the interface. You see, and close. Now we will to flow condition. In this case, I set the groundwater level at 0, and maybe in your case you want to put it over there. It depends on the situation. It's not necessary. It depends on the specific situation. So now we go to the state construction. Okay, in the initial phase, you see that the source is active and the other thing, the structure is not active, deactive. So I will create a new file, new phase. I call it, I change it to file construction, and click OK. In this file construction, we will marking the point by assign the soil layer to the point, assign to the point, and click OK. You can see the point is active. It change the color of the layer. So now we will create a new phase. It is, we can say this, the loading phase with 0 kilonewton. In this phase, we will click it. Actually, I forgot one thing. We will come back a little bit. In this model, we will choose the interface. You see, and you check on this. The interface is selected, and you right click and click active. You see here, active, and this. In this, you click on this, and also right click and click active. Okay, and press ESC. So I will talk again. In this phase, we will active the load by click on this and right click on it and active. And you see in here in the panel, you put is 0. At first, we set the load at 0. And we will create the next. It's a loading phase. Loading phase. You see loading phase. This I call it loading phase 200 kilonewton. And click OK. You see the load is still selected, and I can change the value here. Remember, I will show it again for you. At 200, the value is 1019 minus 1019. Okay, and you just click here to add a new phase. I change the name of the phase. Loading 400. Click OK, and I change the load at minus 2037. Enter, and just make a new loading 600. Click OK. Still selected, and change the value minus 3056. Enter, and you click at the new phase, the loading phase 800, and click OK. And still selected, you can change the value minus 4074. Enter, and create new phase. Change the phase name, the phase ID, loading 1000, and click OK. Change the value to minus 5093, and hit enter, and we will create a new phase. the loading phase at the final step is 1200, and click OK. We will change. The load is still selected, and we will change the value -6112 and hit enter. So we finished the loading state. Now we will define the unloading state. By clicking on this, we add the new phase and change the phase ID to unloading phase, unloading 9800, and click OK. The load is still selected, and we will change the value -4074. Click OK, and we still add the new phase. Change the ID to unloading 400. Click OK. Still selected, and change the value -2037. Hit enter and click final phase. The final phase is unloading at 0, and click OK and change the value, loading value to 0. You see 0. Now we about to finish the definition. Before we finish, we have to do one more thing by selecting the points for curve. To select the point for curve, I will select at the center line, the center of the point, and update. You see selected, and I will update it. And now we can run the program and wait just a minute. It will finish. You see, finish. Here, it's running here. You see the graph, and it's about to finish. It's easy, right? So it finished now. Now you can see the result. I click on this. And we in this case we care about the direction, in the y direction, displacement, actually the settlement of the part. So we click on the deformation and the total displacement in the y direction. Oh, you can see it's nice, really nice here, right? This is the effect zone of the load here. You can change this to see. Okay, and in this you can see at phase 0. Oh, it's too much. It's too much. It's 0. Actually, this result is not too good, because we forgot one thing. I will come back and I will make it right. As the point construction, you see, we make the point. After that, we have to do one thing. We have to reset the displacement to 0. Okay, understand? You click on this. One click. Yeah, and reset. Because the first two phase is okay. We don't need to modify. Just modify this to reset the displacement to 0. Because in this phase, the point is controlled. After construction, the point is just the fixed level. Then we have to reset the displacement to 0 to remove the effect of the construction phase reverse. So now we will run it again. Calculate. And just wait a minute. We will see the result. You can see here. Yeah, it finished. It's done now. The running is done now. So now we will see the result. Just now we will make a little bit easier information. The total displacement, the y direction, you can see here. Now we can see, and the phase is 0, loading is 0. As you see here, this displacement is nearly 0, and it's okay, it's appropriate, because in this phase we don't have any load at this point. Then the displacement must be about 0. So now we will do the x-axis. We will do x-axis like this, to draw the graph to see the displacement, the relationship between the load and the settlement. Now I will delete the old value, and we will input the new value, and we divide the window into 2 windows, and you can see here in the first phase it's nearly 0. We can put 0 here. And in the next phase it is, you see, it is 1.2 mm, and in the next phase for her is a 2.4, and in the next phase you see 3.614, and in the next phase it is 4.864. In the next phase is 1000, 7.702, and we will go to the next phase. This is the final phase of the loading state. It is 11.57. So now we will go to the unloading phase. In the unloading phase, 9.17, and in the unloading phase, this is 6.77. Okay, and in the final phase, final step, is it 4.43, and you can see here. This is the result to see the relationship between the load and the settlement. You see, this is loading state in this line, and this is unloading state. So that's it for our today lesson, and I hope that you can learn something from this video. The video's topic is how to simulate the pi-static load test in Plaxis 2D version 2020. And thank you very much for watching the video, and if you have any question, please comment below in this video. If you want us to make more video on Plaxis, please comment below. We will gather all information and we will make it later. So thank you again, and bye bye for now.